Hello geeks, this is Angelus from Elite PvP, recording tutorial 1 of the tutorial series Let's Make a Memory-Based Bot. So, disabling the client protection, that's the subject of this tutorial. Probably it'll extend to part 2 maybe, I'm not sure, we'll figure it out. Anyway, so the first thing I'm going to do is to disable the client protection. How to do so? We're going to do that, we're going to do it step by step, and we're gonna do it using OLE debug, aka OLE dbg. Now, for those who doesn't know what OLE debug is, all you gotta do is simply Google it. Google is your friend. However, now I already have it installed on my PC, but I'm just going to download it now and show you how to install it and do all that crap, and we'll get started. So I'm going to open my web browser and I'm going to type OLE dbg 2.0, and I'm going to open the first link, and I'm going to, now if you can't find your way around on this page, all you gotta do basically is just click right here where it says OLE dbg and your download should start. Okay, now that consider that I did hit OK and I saved it somewhere on my desktop, in a new folder, whatever, which is basically what I did. I already have it downloaded and ready right here. I'm just going to right click, extract it to this folder. I'm just going to rename it real quick, and I'm going to call it OLE, and then I'm going to open this folder. I'm going to right click on OLE dbg.exe, go to properties and go to compatibility, and make sure it's running as an administrator under the privilege level. That's important, so you gotta do that and before you even start OLE debug. However, now that I've done that, let me just fix my toolbar so it auto hides. Okay, now that I've done that, I'm going to launch OLE debug, and I'm going to go to, you can either click this button here or you can just hit Alt O on your keyboard and it'll open the same dialog. You can also access it under options here. Anyways, we're going to go under exceptions tab, and we're going to hit or check this checkbox right here where it says ignore also the following custom exceptions or ranges, and I'm going to add range. Now we're going to leave this box as is, and we're going to change this to we can probably select from this list, which is, we're going to select the last exception in this list, and we're going to hit OK, and I'm going to actually delete this. I'll just add range and also leave this box as is, and just type FF. So you gotta type F 8 times. I'm not gonna explain what that mean or does, however you gotta figure it out on your own. You have a brain. So now that I've done that, I'm going to go under the directories tab, and as you can see, it has already copied the directory where we have OLE installed or extracted. So I'm just gonna go to that directory, which is right here, and I'm going to right click, create a new folder, and I'm going to call this UDDs, and a new folder, and I'm going to call it plugins. Now we're not going to be using plugins in this tutorial. We're going to do it all manual, and we're just going to do it ourselves. But the UDDs folder, what the UDDs folder is needed for is just basically for OLE to install all the .udd files that it'll create, and what those files contain is a lot of helpful information that OLE is going to collect along the line while you debug programs or attach to programs and shit. So basically the purpose of these files is to make your life easier. So just hit OK, Now that we've done that, I think we're all set. Yeah. So the first step is to open conquer.exe. Before we open conquer.exe, now for those who had never worked with all debug, I will not explain what all these button does and whatever. All you gotta do simply is keep your mouse long enough on each button and it'll show you a helpful tip as to what that button does. So if you still don't understand stuff, all you gotta do is also Google it. Google, and again, is your friend. So I'll just click File, Open, and I have a clean installation of Conquer Online, and it already took me to that folder already. I think because I've opened it earlier. Anyway, and I'm going to navigate to my Conquer Online client folder, and I'm going to find conquer.exe, and then I'm going to hit Open. Now you can see it analyzing shit down here. All these modules that Ollie is analyzing, it'll just collect as much data as it needs, and it'll save it in the UDD files when you close Ollie debug. So I would recommend that you let it finish. It'll make your life easier. So while it's doing that crap, I forgot what I was gonna explain. Never mind that. Anyway, I'll just pause the video until it's done. Okay, now that all is done analyzing the models, if you look at the lower right corner, you'll notice that it says terminated. Basically, all the debug is telling you this process was terminated somehow. So to figure out what terminated the process, we're gonna have to find our way around and find out what really terminated the process. And to do so, before we do so, this is just another trick to stop you from opening conquer.exe in Ollie debug. Even though if we go to View, Executable Models, or hit Alt-E, like this, you can see that we have basically all the models needed to start Conquer Online or Conquer.exe, and if we select Conquer.exe, double click on it, you can see that it'll take us really to inside the Conquer.exe, and you can see the assembly code. That's not a really helpful thing, because as long as we can see the code, I can find my way around and find out what really has changed. But for you, maybe there's some people out there that doesn't know what to do or where to go or what to look for. That's going to be kind of like annoying. However, let's figure out what really killed our process. So first thing I like to do is to analyze the stack and see what was the last thing that this program did before it terminates. So this is, again, for those who doesn't know what all this nonsense on the screen is, this is your main CPU window, and this is the register window, this is the stack window, and this is the memory view or the memory dump. So we're going to head to the stack window, and we're going to scroll down and see if we can find something helpful. Alright, now that I scroll down a little, and I can see a call to kernel32.exit process. So I need to know what the exit process function does. Basically, I already know that the exit process function is to kill the current process. So that's useful, and I can like start here. So what I'm going to do is just select this line where it says return from DLL blah blah blah. This is just a return address. So if I select it, click on it, left click on it, and then click enter, it'll take you straight into this function. And if you noticed, now we're inside the kernel32 model, and straight inside the exit process function. So what I'm going to do is just I'm going to right click and I'm going to go breakpoint, hardware breakpoint, and I'm going to make sure it's on execution, and I'm going to select slot 2, and then I'm going to hit OK. What that does is just simply place a hardware breakpoint on this certain address that we right clicked on. So now that I've done that, we need to make sure that we can actually hit this breakpoint before the process exits, or else it's useless. So let's just click on this button here. It'll restart the current process, and the breakpoint was triggered, and right now we are at the top of the exit process function. Now that my breakpoint was triggered, I'm going to go back to the stack, and I'm going to check what really called this function. The stack can really help me, so I'll just go back to the stack, and I'm going to click on the very first return address, and if you notice, it says return from TQANP to TQANP. TQANP is basically another DLL file that TQ team decided to add, and to put some crap and anti-debugging shit inside it. We're gonna simply bypass that. So I'm just gonna click on it, left click on it, and then hit enter. It'll take me straight into TQANP model, because this return address returns to this address, which is inside the TQANP. So to analyze this model here, which is TQANP, and I'll just hit Control A on my keyboard. Now what this dialog box is telling you basically is that this model contains sections of code that are either compressed or encrypted. We don't really care about that right now. Just hit yes. As you can see, the helpful stuff showed up after the analysis. So now this return address returns to pop ECX at this address here. So above it, right above it, one line, it says it calls a certain address, and this address is also inside TQANP. So basically, this return address is to return from this call to this address here. So the program continues executing from this address here. So what I'm going to do is one line above that return address, and I'm going to right click, and I'm going to place a hardware breakpoint again, but I'm going to make sure the slot 1 selected also on execution, and I'm going to hit OK. Now I'm going to restart the program and hope that this breakpoint will be triggered. So restart. Yeah, I know. Okay. And it did. However, let's hit Control A again to analyze the process. And what I'm going to do now is I'm going to hit F8. So F8, what F8 basically does is step over the function. F7 to step into the function. It's mentioned right here. If you keep your mouse long enough, it'll show you what these buttons does. So get used to using the shortcuts, because it's really useful. It'll make everything faster. You don't have to keep clicking buttons here and shit. However, now when I hit F8, basically the program is going to go inside this call, execute this code right here, and then return at this return address here. Return here. Anyway, so if somewhere along any of these lines the exit process function was called, what basically is going to happen is that my second breakpoint, which is now placed on the exit process function, will be triggered. But if nothing happened and the program executed all this code and then returned and the breakpoint was not triggered, I know that it did not call it. So I'm going to hit the star button on my keyboard to go back to where the current pointer for the debugger is, and I'm going to hit F8. Now as you can see, no breakpoints were triggered, nothing happened, so I know it did not really call that exit process function. So I right click here, breakpoint, and I can safely delete this hardware breakpoint so I can use it somewhere else, because all you can use is 4 hardware breakpoints. You can't set more than 4, so we gotta keep it like limited. Anyway, so I'm going to keep on the F8 right now. I'm going to hit F8, F8, and continue with the process until I find something interesting, something useful. So continue. Now it decided to jump, and discard all of this, ignore it, just jump. Now it's in the process of returning. Now it returns. Okay, now this function did not really call the exit process. Now remember that we were tracing the process execution backwards. The stack works backwards if you're going to use the stack to analyze stuff. You can't go upwards and start from here. No, because the stack address, imagine the stack address like I don't know how to give you an example for that, but it's like a stack of towels. If you have a stack of towels and you keep stacking towels on top of each other, you're not just going to go into the middle of that stack and just pull one towel, because it'll all fall apart. You're just gonna have to grab the first one on top. So basically that's what this stack is. First in, first out. So now that we know that, that's the reason that we're supposed to trace backwards. Anyway, so I'm going to continue with the F8 again. F8, F8. Now it's pushing the arguments. I know that with these arguments the function can do something, but I don't know what that thing is. So what I'm going to do is just right click, again, breakpoint, hardware breakpoint, and I'm going to make sure on execution, slot 1, and I'm going to hit OK. Now, if I hit F8, again, if the exit process function was called, my second breakpoint will be triggered. So let's hit F8. Now we can see that it did trigger that breakpoint and the exit process function was called. So now we know that this call here, where my second hardware breakpoint is, really calls the exit process somewhere along the line. So I'll restart my process and it'll take me straight back to this breakpoint here, which is really useful, and it'll keep you on track without having to retrace the whole thing from square 1 or square 0, whatever the term is. Anyway, so now that I'm here, I'm going to hit F7 to step into this function, but before I do that, I'm going to right click, breakpoint, hardware breakpoint, and delete this breakpoint so we can use it somewhere else. And I'm going to hit F7. Now I'm inside that call. Okay, so what this call does basically is it moves the word value from the stack, which is the argument 2. Argument 2 value right now equals 1. So it's going to move 1 into EAX, which is currently 1, so nothing will change. And then it'll subtract it by 1, subtract EAX by 1, and then this subtracting process, it sets the bit flags here. I don't really recall which bit flags. I think it's P or Z, and then it checks whether P or Z equals 1 or 0, and it jumps accordingly. So we're not going to really bother with that. You can Google it if you want to really know what that does. But let's continue with the F8. Now EX still 1, nothing has changed. Now subtract EX by 1, EX becomes 0, and then as you can see here, it says jump is not taken. So with the jump not taken, G and Z basically stands for jump not zero. Jump not zero, again, like I said, it compares the bit flags here. I'm not sure whether it's B or Z, but it checks whether it's 1 or 0 and it jumps accordingly. So what we understand from this process here, from this these 6 lines, that it either jumps to this address here. You can see this little arrow right here. It either jumps or it doesn't, and it calls this address, and then it continues and returns. So what we're going to do is right underneath this jump right here, we're going to set a hardware breakpoint again. Make sure it's on execution, slot 1, hit OK. And the reason we did that and we didn't set the breakpoint here or here is to make sure that it's really executing or calling these 2 addresses. If it's not, then it's useless. And like for me right now, I'm sure that it's calling this or this calls, or both of them actually, because if it didn't, there's nothing else to call the exit process function. So what I'm going to do is I'm going to hit F8 and I'm going to hit F8 again. Boom, the exit process function was really called. So let's restart our process. It'll take us, oops, what just happened? Okay, I think our breakpoint or our hardware breakpoint went poof. Yes, it did. Anyway, I'm going to delete this. Okay, delete. And I'm going to return here, and this one returns. Okay, I'll fix this by retracing the whole thing all over again. I guess I'm going to have to do that. I don't know why did that breakpoint disappear, but oh well. So I'm going to do the whole process all over again. You don't have to watch this, you can skip this bullshit if you are not interested. So again, I'm going to set a breakpoint. Actually, yes, I can set it here. Hardware breakpoint, okay. And I'm going to restart the process. My breakpoint was triggered. I can right click, delete, and then continue executing this function until return. And if you remember, this is the function that we were inside right now. I'm going to hit F7. It'll take me inside that call, and then again I'm right where we left off. So now that we know that this call right here called the exit process function, we're going to try and do what the program does sometimes, which is discarding these 2 calls and jumping straight to move EAX1 and then return. So how do we do that? We do that by simply double clicking this line right here, the GNZ instruction, and then we're going to change it from GNZ into GMP. GMP stands for jump. Jump doesn't check for any conditions, any bit flags. It just jumps wherever you tell it to jump. So with that set, we're going to hit assemble. That will edit the code, modify it to what we tell it to do, and then we're going to test this program and see if it'll terminate or not. And we do that by simply hitting the play button here, which will continue executing our process normally. So let's click that, or before we click that, you might want to just highlight this, right click, edit, and then copy it as a table, and you can then open a notepad and then you can paste it here, and as you can see, it'll copy the address of each instruction and the assembly instructions and the binary code for each assembly instruction. So you can keep that for like later use, or maybe if you lost your way, or if you're tracing it and your breakpoint was gone, just like what happened to us right now, you can go back to this model here, TQANP, and find this function based on the address right here, or you can simply right click, search for, and you're going to search for a sequence of commands. So what we're going to do is simply play the program. Boom. As you can see right here, it says conquer the model entry point. So we are inside the model entry point and the process did not really terminate. So that's really good, and what that tells us is that we did really bypass that exit process function and what it did. So as long as that works, let's just restart our process, and we want to make those changes that we just made permanent. So now that I know what to change and where to change it, I can simply go to View, Executable Models, or hit Alt-E on your keyboard. It'll open this dialog for you, this window, and you're going to select, instead of conquer.exe, you're going to go to tqanp.dll. You hit enter, it'll take you inside this model, hit Control A to analyze it, retrace it back. That's really easier to do. So we're at the exit process function again. We click right here, it'll take us back here. I'm going to straight set the breakpoint on the return address right here. So breakpoint, hardware breakpoint, slot 1, okay, restart, and then I'm going to trace it back again. Okay, this is the function that we need to edit. Now I'm going to double click on this again, change it to GMP instead of GNZ, and I'm going to click assemble, and with that done, I'm going to click on that, left click on that line that we just changed. I'm going to right click, edit, and I'm going to copy to executable. So that's just going to tell you that you did some modifications and you need to save them. I'm going to ignore this box and I'm not going to display it anymore. And I'm going to hit OK. And right now what we're doing is we're saving our work, we're saving our edits and modifications. So to save that, you're going to click the X button right here. It'll ask you if you want to save it. Hit yes. It'll open the same directory where your conquer.exe exists. So all you need to do is hit save, and as you can see, it'll give it the same name too. So excuse me, we're just going to hit save. It'll ask you if you want to replace the current DLL file, and you're going to hit yes. So with that done, let's try and restart our process and see what's going to happen. Okay, this is because I didn't delete my breakpoint, which is stupid. So let's just delete it and continue running the process. As you can see, everything worked just fine. And right now we're at the model entry point. So if we hit play and continue running the process, it'll finish analyzing those models inside this process, and it should pop the dialog that asks us to run play.exe. That's only in case if everything worked as intended. So we're waiting for that message box. There it is, which is cool. Now I'm going to terminate conquer.exe. As you can see, it'll still do that crap, and then it'll save all the .udd files. So if we go back into all udd files, oh shit, why did it save them here? It was supposed to save them inside this folder. So let's go back and check it out. Oh, I'm sorry. The reason is that I did not set the directories, and we're going to set them now. We're going to set the .udd files directory. We're going to click here, select the UDDs file that we created earlier, hit OK, and then we're going to select the plugins folders that we created earlier, hit OK, and then hit OK. What that will do is all these .udd files were supposed to be inside the .udd files folder, or the folder that we just created. So I'll just move them inside that folder. Now we're done. Okay, with that done, there's a second problem that we're going to face, which is if we run or play Conquer Online and then we try to attach to it and then log into the game, what will happen is that it'll also terminate the process. So if we play Conquer.exe, go to File, Attach, and then you're going to find Conquer.exe, hit Attach, and then it'll probably load all the way, and I'm going to pause the video until it's done. Okay, now that Ole is done analyzing those models, as you can see, it'll break somewhere inside the process, and now it chose to break inside user 32. So what I'm going to do is I'm just going to hold the shift button and I'm going to hit F9, and it should continue running the process, and as you can see, it'll say running right here. So ignore those access violations exceptions, because as you can see, if you open the log here, it'll just keep on and on and on and on. It'll never stop. However, I don't know why, but it's just doing it. I don't really care. Anyway, if we switch to Conquer.exe, you can see that the process is running and everything works just fine. So let's try and log in. Let me check. If I can remember an account. Okay, 5. Oh my god, this annoying fucking message. It's just retarded. It pops up every single time I try to log in. Okay, now it's trying to log in. And again, as you can see, we our breakpoint on exit process, the exit process function was triggered, meaning this process is trying to terminate itself. So again, we're going to go back to my favorite thing, which is the stack. As you can see, another call to kernel 32 exit process, and derived from or called from anti-robot client blah blah blah. So the exit code is 0. We don't care about that. Now, what this tells us that somewhere inside this DLL file here, the anti-robot client, the exit process function is being called for some reason. Probably it detected that we're using a debugger or something like that, and it wants to terminate the process. So what we're going to do is just basically go to this line here, and as you can see, it says return from anti-robot client to anti-robot client. So what that tells us is that anti-robot client is calling a function inside itself, and let's go and check what that function is. So select it and hit enter, and it'll take you straight into anti-robot blah blah blah. So as you can see, I, I mean, like I said earlier, this address here, right here, is the address as to where this stack address here will return. So as you can see, it says return to blah 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 from blah blah blah. So if you compare those addresses, this address is equal to this address. So we know that it'll return into this instruction here, and then execute it, and then continue executing these instructions, and then return. So now that we know it's supposed to return to this instruction, we know that the call above it is what called this function. So this is the return address for this call. So we go one line up, right click, breakpoint, hardware breakpoint, slot 1 on execution, OK. Now let's you can either restart the whole process, restart Conquer Online, and then reattach it, and then let it run and log in until this breakpoint hits, and then we can go inside this function and see what it's doing. Or we can simply just click on that function. Let's go back to it. Click on this call and then hit enter. It'll take you inside this function right here. So if you look closely, this function is calling this address here, anti-robot client, blah blah blah. We don't know what it does, and then right after it calls that address and returns. It pops ESECX, pushes the exit code which is 0, and then kills the process. So basically this function is a certain kill for the process. This function will never return any other results other than killing the process. So this is bad. We don't want this function at all. So again, click on this line, go back. So we're here, and I don't want to restart the whole thing, so I'll just delete this breakpoint here. And what I'll do is check what called this whole function here, right here, from the start of the function until the return. So we need to know what called it. To know that, all we do is just go back to the stack and find the second return address underneath this, which will be this address. As you can see, return also from TQANP to TQANP. So let's select this line, left click on it, and then hit enter. It'll take you to the function where it's been called. What I'm going to do, I'm going to take a wild guess, and I don't recommend that you do that every time, but I'm just guessing that this function right here goes in, checks for the processes, checks maybe for this debugger present function, and then if yes, it kills the process, no, it returns, and it continues. So what I'm going to do is just right click on it, edit, fill with NOPs, and then I'm going to save this permanently and then try and run the process. So one thing that I've never mentioned, back up your files, back up your DLLs. Now you know you're inside anti-robot client.dll. All you gotta do is go into your client folder, copy anti-robot DLL somewhere else, and then paste it so you can replace this file if you damage it. So that's what I would do, because if you don't know what you're doing, you can't really restore this stuff unless you're gonna repatch your client from I don't know which version. Anyway, so now that I've set this to NOPs, I want to save it permanently. So right click, edit, copy the executable, and I'm going to hit the X button here, and it'll ask me if I want to save it. I'll hit yes, and again it'll take you into your Conquer client directory, and it'll give you the name of the model. Just hit save, replace it, yes, and then I'm going to kill the process and all the debug. Yes, I know that. Now if we try and run conquer.exe and then we go back and run all the debug and then file, attach, conquer.exe, attach, hit shift F9 to continue running the process. Wait until it's all the way in. Okay, it's running as you can see. Now I can go back, switch to Conquer and try and log in. Okay, let's hope it'll work. Boom. Everything works just as intended and we're inside the game, so that's cool. Oh boy. Oh boy. This game is shit. It went shit. It's just horrible. Nothing is playable in that game anymore. Anyway, now that we've done that, we have all the access we need to modify Conquer Online, to find the functions that we want to find, and to build our memory-based bot. So in the next tutorial we'll be dealing with finding the addresses, maybe, and finding the addresses of functions that you need to use in your memory-based bot. So I think that's it for this tutorial, and I hope I didn't make it very long. I think it's very long by now, so until the next tutorial, be safe.